Girls, this is Mrs. Zui coming to you live from our kitchen, and this is Emily. Say hi, Emily.
Hi, Emily.
Say hi, boys and girls.
Hi, boys and girls.
And today we're coming to you to teach you a little bit about inequality. So hopefully you have your math notebook and you're ready to take some notes. Make sure to set them up Cornell style if you want to, so that you can have your questions and your summary at the end. So let's go ahead and get started. So hopefully by the end of this lesson, you're able to solve inequalities in a single variable and you understand what I call the golden rule of inequalities. That's not what it's really called, but that's what I call it because it's so important that you understand what that rule is and how it applies to inequalities. And also you should be able to compare and contrast solving equations and inequalities. There's some similarities, there's some differences, and you have to really keep track of them so that you know what to do with any given problem. So recall from the activity in class today that an inequality is very similar to an equation in that you have values on both sides. However, in an equation, the sides are equal. So if we think back to the scale reference that I made before, the scale is balanced. However, in an inequality, the sides are not equal. One side is greater than the other, so your scale is unbalanced here. One side will be heavier than the other. So rather than having an equal sign, what we have are these inequality symbols. So the first one will be greater than. We have a less than symbol. We have greater than or equal to, and less than or equal to. And because there are so many possible solutions, we must always use a graph to show all the possibilities. There's no way we can list them all, but we can show them on the graph visually to show what all the solutions are to an inequality. Now, when you're solving inequalities, you have to use the exact same steps we used before when we were solving equations. In other words, we use PEMDAS backwards, so we have to undo all those steps backwards. So if you have parentheses, that comes last. Adding or subtraction comes first. Or you can remember don't call me after midnight, which stands for distribution, combining like terms, moving the variable, adding or subtracting, multiplying or dividing. So the steps are exactly the same, nothing changes there. However, the main difference is this golden rule of inequalities that I was talking about before. So the golden rule of inequalities basically says that if you ever multiply or divide by a negative number, the inequality symbol flips. So say you had a less than symbol and you happen to multiply or divide by a negative number while you were solving, then that symbol goes from less than to now greater than. So you have to remember to flip if you multiply or divide by a negative. Now you may be asking yourself, why is that? Why does the inequality symbol flip when I multiply or divide by a negative? Well, I'm so glad you asked that question. So let's look at the numbers 3 and 2. We know 3 is greater than 2. Cool, not a big deal. Now let's multiply both sides by negative 1. So now on the left, I have a negative 3, and on the right, I have a negative 2. However, negative 3 is no longer greater than negative 2, so I cannot keep my symbol greater than. I have to flip it now to less than because negative 3 is less than negative 2. So because we multiply by this negative, my inequality symbol flipped along the way. And the same thing happens when you divide by a negative number. So you have to keep that in mind. When you multiply or divide by a negative, your inequalities flip. So let's put all that information together and solve this inequality here. Remember, the steps for solving are exactly the same. The only difference is that golden rule of inequalities, which means that if I multiply or divide by a negative, my inequality symbols will flip. So first thing I need to do is distribute. I'm going to distribute this 2 here. This 4p comes straight down. 2 times p is 2p. 2 times 7 is 14, less than 8. Cool. After I distribute, I got to combine my terms. So in this case, I'm going to combine the 4p and the positive 2p. And remember, like I always say, if they're on the same side, don't change the sign, just combine. 4p plus 2p, that's 6p, plus 14 is less than 8. I don't have to move any variables here because I only have p's on the left side of the inequality symbol. I do have to, however, add or subtract. In this case, I'm going to subtract 14 from both sides. So I'm left with 6p on the left is less than 8 minus 14, that's negative 6. Now notice that I went from a positive 8 to a negative 6 here when I subtracted. I don't need to change my inequality symbol here because I didn't multiply or divide. So the golden rule does not apply here. I only subtracted, so it stays the way it is. And now final step is to divide by a positive 6. So p is less than negative 1. So again, I didn't divide by a negative here, so my inequality doesn't flip. However, I'm looking for all the values of p that are less than negative 1. What does that mean? Well, if I look at the number line, and I'll try it up here since I'm out of room. If here's 0, here's negative 1, I want all the numbers less than negative 1. So that would be negative 2, negative 3, and so on and so forth. Now, because there's so many numbers, we use the graph to show visually what the solution to this inequality is. So because it cannot equal negative 1, I have an open circle on negative 1, and then I want all the numbers less than that. All the numbers this way. And that pretty much covers all the numbers because I drew this arrow less than negative 1. And make sure that when it's less than, not equal to, I have this open circle on negative 1. Okay, so let's go ahead and try another example. Now remember, when you're solving inequalities, it's the exact same steps as when you are solving equations. So I'm going to start here by distributing the negative 2. Please watch your signs. That 2 is in fact a negative. So I'm going to bring down the 15 and the 5. The 5 I'm not touching yet because the only thing I'm doing is distributing. So this becomes negative 8m minus 14. From there, I have to combine like terms. And remember, if they're on the same side, don't change the sign, just combine. So this turns into 15 is less than or equal to negative 9 minus 8m. My next step would be to move the variable, but I don't have any variables to move here, so I'm going to add the 9 to both sides of the equal sign, or sorry, inequality symbol. This becomes 24 is less than or equal to negative 8m. Then I divide both sides by negative 8. So because I'm dividing by a negative, you have to be really careful here and flip that inequality symbol. So it's no longer less than or equal to, it is now greater than or equal to. So negative 3 is greater than or equal to m. Now don't forget, because there's so many solutions, it is important that we show them on the number line. So I'm going to put 0 here, negative 1, negative 2, negative 3 here. Now in this case, it's less or greater than or equal to. Sorry, I had to pause and get Emily some chips. Okay, so back to graphing. So because it's greater than or equal to, in this case, it includes the negative 3. So because the negative 3 is included, I have to make sure that it's a closed circle. Now pretend that is a nice circle there. Okay, so it's a closed circle. And most students get confused when the variable is on the right-hand side, but don't worry. All this is saying is that you want all the numbers that you can plug into m that are smaller than negative 3. Negative 3 is the biggest because the inequality symbol, the bigger part of it, is towards the negative 3. So negative 3 is the biggest, and I want everything smaller. So that means, in this case, I go to the left of my inequality symbol. So I'm going to the left here. So all the numbers less than or equal to negative 3 are now shown on my graph. All right, let's go ahead and try this one. So again, same steps as before. Distributing, no need to do that here because I don't have any parentheses. Combining like terms, on the left, I can't combine the 3w and the 2. On the right, I can't combine those either, so don't need to combine. I do, however, need to move the variables because I got 3 w's on the left and 2 w's on the right. So I'm going to move the 2w over by using inverse operation. So 3w minus 2w, that's just w, plus 2 is less than 5. Cool. From there, I need to subtract the 2. W is less than 3. So, of course, I have to graph this on my number line because we have so many solutions that we can't possibly list them all, so we show them visually. So here 0, 1, 2, 3. Now, in this case, it's going to be an open circle because I don't have that equal to symbol at the bottom. So it's an open circle on 3, and I want all the numbers that are less than 3. Less than would, again, be to the left. And there you have it. There's my graph. There's my solution. So all the numbers that are less than 3 are now shown on my graph. Okay, so now in this example, we have to find the error. So we're solving inequalities. Someone solved them for us, and there's mistakes in both of these problems. So let's go ahead and try and find those mistakes. So in the first one, it looks like they went from 3x. They still have the 3x in the next step. However, this 3 is missing. So I believe what they did was they moved it to the other side, which means I would have had to subtract the 3 since I'm moving it to the other side of the inequality symbol. And 5 minus 3 is 2, so we're okay there. Next, what I would need to do is move the variable. I have this negative 2x on the right-hand side, so I would have to add it to the other side. So this should have been 5x here. So what this person did was just combine the variables. However, they're on opposite sides. So you should have used inverse operations. So that was the correct step there. Now for this next one, first thing we need to do is distribute. So this should have been 4n, oh, there's a mistake. It should have been 4n plus 8. They did not distribute all the way through, which means they probably messed up the rest of the problem because they did not distribute all the way. Okay, so it's important that you see these mistakes so that you are aware of them and you don't make them yourselves. Make sure that if they're on opposite sides, that you use inverse operations. Make sure you distribute all the way. Make sure you watch your signs and make sure that if you multiply or divide by a negative, that you flip the inequality symbol. All right, so a couple of questions that I want you to ask yourselves as we wrap up this lesson is first, what steps do we follow to solve multi-step inequalities? And what do we need to remember about multiplying or dividing by a negative when we're solving inequalities? So if you can answer these two questions, then you've learned and mastered the concept for today. Otherwise, bring your questions to me tomorrow and we'll go over them in class. So on the next slide, there's 4 problems that I would like you to try either on scratch paper or in your notes. I want you to try them, but do not erase your mistakes. If you know you made a mistake, don't get frustrated, don't erase them. I want you to bring them to me so that you and I can find your mistakes together and fix them. And that way you get a better understanding of how to solve inequalities. Also, if you have any questions, please make sure you write them down so you don't forget them by tomorrow when you see me, and that way I can clarify anything that you might need help with. All right, so here are the 4 problems that I would like you to try. Please remember that you need to distribute first, then combine like terms, then move variables, then add or subtract, and then multiply or divide. Also, do not forget the golden rule of inequalities, and that is if you multiply or divide by a negative, you have to flip the inequality symbol. And last but not least, make sure you graph your solutions so that you can show visually what the solutions are to your inequalities. And here's Emily eating her chips. Say goodbye, Emily.
Goodbye, Emily.
Say I'll see you guys later.
I'll see you guys later.
Say make good choices.
Make good choices.
Bye.
Bye.
Bye, boys and girls. I'll see you guys tomorrow.